So we have an object thrown upward leaves a thrower's hand. And we have our graphs here, so let's do our Oizerga first. We look quickly, VT, 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 VT. So Oizerga. So we have 0, 0. The y-axis is v, x-axis is t. The things we can read are those axes, v and t. The slope is delta v over delta t, which is the acceleration, and the area is v times t, which should be the distance, because we're talking about speed. So an object is thrown upward. So the ball goes upward, and we know it's going to slow down. And at the top, the velocity, the speed is 0. And then it increases and falls back down. So in the beginning, we might say throw it at 20 meters per second. At the top, it's 0 meters per second. So we need to see it start with a high velocity and go to 0. So just that segment of it tells us that this choice is in. This one is not. It says the velocity starting is 0. Now, the initial velocity is the velocity from after it's leaving the hand. So we're not talking about it being at someone's side. We're talking about after it leaves the person's hand. And so for that reason, these two are out, because they're starting with a 0 velocity. The question is the velocity change gradual, or is it sudden? Now we show this one, the speed decreasing to 0 and then increasing. The acceleration caused by gravity, we have already said, we knew from the Earth all the way out even to the ISS, is a constant 10 meters per second squared. It doesn't change. The change is so small that we don't see any changes there. And so that acceleration is constant. And since the acceleration is the slope, constant slope, that gives us choice A.